Hey everyone, so today's lesson is intended for 8th grade. Our learning objective is for students to learn the definition of congruence and the related notation, how to prove congruence with the sequence of rigid motions, along with knowing the properties of congruence are similar to the properties of the 3 rigid motions. And this mathcast is created by me, Hannah Cuppernall. We'll start off by going over our definitions. Congruence. All angles are congruent and all sides are congruent when they are the same size. So if an angle has 90 degrees and another angle has 90 degrees, these two angles have congruence. Rigid motions. Any way of moving all points of geometric picture in a plane such that the relative position and distance between points stays the same. So with these rigid motions, which are translation, rotation, and reflection, any way that the geometric shape moves along the plane, the area, the sides, and the angles will all remain the same. Translation, a slide of a geometric figure. Rotation, a turn of a geometric figure about a given point. And reflection, a flip of a geometric figure all over an axis. So this example right here is stating that A is congruent to A prime. This symbol right here is showing congruency, and this symbol right here is showing that this right here is an image of this right here. So the triangle shown above, we will name triangle A, B, C. So if I move image A, B, C over here, this rigid motion of moving A, B, C will create an image of triangle A, B, C prime. And these points will become A prime, B prime, and C prime. This rigid motion, however, does not change the size, shape, or the area of the figure. With this being said, line BA is congruent to line BA prime. Line BC is congruent to line BC prime. And line AC is congruent to line AC prime, along with all of the angles in the triangle. So angle B is congruent to angle B prime, angle A is congruent to A prime, and angle C is congruent to angle C prime. Again, this motion of moving the image without changing the size or shape of the figure is a translation. So we have a figure A, B, C, D. Now if we draw a line and say we want to reflect the figure over this line, it's going to be a mirror image. So it will look somewhat like this. Now, the figure is not supposed to change size nor shape, but the points of the figure are just reflected over the line, so the image will look somewhat backwards. Now here we have triangle ABC, and we are going to show a rotation of ABC. So if we have this point, and we want the image to rotate about that point, say we want to rotate it 90 degrees, it's going to rotate about the point, 90 degrees. The distance of B to this point does not change. The distance of A to this point does not change. And the distance of C to this point does not change. Nor does the size, shape, or area of this image right here.